Welcome back. Sir Cincy, for those watching for the first time. Today we want to calculate the homogeneous solutions and the particular solution of a system given an unhomogeneous linear system below. We find that an unhomogeneous linear system is basically a linear system in the form AX is equal to B. Now, to find the homogeneous solution and particular solution, we need to perform a double REF, that is row reduction. Now, to perform a row reduction, we need to write this in the form of augmented matrix. That will be coefficient here is 1 in front of x1, coefficient in front of x2 is 1, coefficient in front of x3 is 1, coefficient in front of x4 is 3. Our B is 2. Then coefficient in front of x1 is 2. Since we don't have x2, it's 0. Coefficient in front of x3 is minus 1. Coefficient in front of x4 is 1. Our B is 0. These are our B values. Coefficient in front of x1 is basically 1. Coefficient in front of x2 is 2. In front of x3 we have minus 2. In front of x4 we have 1. And the B is 1. Now this is our augmented matrix. Now we want to perform a row reduction, that is double REF. Now this is our leading entry. Everything below our leading entry should be 0. 2 should be 0, 1 should be 0. Let's start by making 2 0. We'll basically have minus 2, row 1, plus row 2, and our answer to row 2. So we maintain row 1, which is 1, 1, 1, 3, 2. Minus 2 times 1 is minus 2. Minus 2 plus 2 is 0. Minus 2 times 1 is minus 2. Plus 0 is just minus 2. Minus 2 times 1 is minus 2. Minus 2 plus minus 1 is minus 3. Minus 2 times 3 is minus 6. Minus 6 plus 1 is minus 5. Then we have minus 2 times 2 is minus 4. Minus 4 plus 0 is minus 4. Then we have 1, 2, minus 2, 1, 1. Let's have, want to make this one 0. Let's have row 1 minus row 3. And our answer to row 3, since it's row 3, we want to make this one to be 0. Now here we maintain row 1, 1, 1, 3, 2. Since row 2 is all negative, let us have negative 1, row 2. So you have 0, 2, 3, 5, 4. So it was row 1 minus row 3. Row 1 minus row 3. 1 minus 1 is 0. 1 minus 2 minus 1. 1 minus minus 2, 3. 3 minus 1, we have 2. Then, 3 minus 1 is 2. 2 minus 1 is 1. Since we want our second row to have a leading entry in the second column, let's interchange negative row 3 with row 2. Let's interchange negative 1 row 3 with row 2. Here we maintain row 1, 1, 1, 1, 3, 2. Now we interchange row 2 with negative 1, row 3. Now our row 2 will be negative 1 times 0 is just 0. Negative 1 times 1 is 1. Negative 1 times 3 is minus 3. Negative 1 times 2 minus 2. Negative 1 times 1 minus 1. And now our row 3 is now row 2. 0, 2, 3, 5, 4. Since this is our new leading entry, everything above 1 and below 1 should be 0. So to make this one 0, we'll have row 1 minus row 2 and our answer to row 1. Now our new row 1, we have 1 minus 1, 1, 1 minus 0, it is row 1 minus row 2, 1 minus 0, 1 minus 1, 0, 1 minus 3, that is 1 plus 3, 4. Then you have 3 minus 2, that is 3 plus 2, 5. Then you have 2 minus 1, that is 2 plus 1, which is 3. We maintain row 2, 0, 1, minus 3, minus 2, negative 1. Maintain row 3, 0, 2, 3, 5, 4. We want to make 2 to be 0. We'll have negative 2, row 2, plus row 3, and our answer to row 3, since it is this 2 we want to make to be 0. So we maintain row 1 and row 2, that is 1, 0, 4, 5, 3. Maintain row 2, 0, 1, minus 3, minus 2, minus 1. So our row 3 is minus 2, row 2 is minus 2 times 0, which is 0, 0 plus 0 is just 0. Minus 2 row 2, that is minus 2 times 1 is minus 2. Minus 2 plus 2 is 0. Minus 2 row 2, that is minus 2 times minus 3, that is positive 6. 6 plus 3 is 9. Then we have minus row 2 plus row 3. That is minus 2 times minus 2, which is 4. 4 plus 5 is 9. Then minus 2 times minus 1 is 2, positive 2. 2 plus 4 is 6. We want to make this one a leading entry. Let's multiply row 3 by 1 over 9. So we maintain row 1. It's 1, 0, 4, 5, 3. Row 2 is 0, 1, negative 3, negative 2, negative 1. Row 3 will be 0, 0, 1 over 9 times 9 is 1. 1 over 9 times 9 is 1. 1 over 9 times 6 is 2 over 3. Since now this is our leading entry, everything above should be 0. So let's start by making this one 0. We have 3, row 3 plus row 2, our answer to row 2. So we maintain row 1, 1, 0, 4, 5, 3. Now our new row 2 will be 3 times 0, which is 0. 0 plus 0 is just 0. 3 times 0 is 0. 0 plus 1 is 1. 3 times 1 is 3. 3 plus minus 3 is the same as 3 minus 3, 0. Then we have 3 times 1, which is 3. 3 minus 2 is 1. Then we have 3 times 2 over 3, which is 2. 2 minus 1 is 1. Then we maintain row 3, 0, 0, 1, 1, 2 over 3. Now, this 4 also should be 0. That is minus 4 row 3 plus row 1. Our answer to row 1. Therefore, our new row 1 will be minus 4 times 0 is 0. 0 plus 1 is just 1. Minus 4 times 0 is 0. 0 plus 0 is just 0. Minus 4 times 1 is minus 4. Minus 4 plus 4 is 0. Minus 4 times 1 is minus 4. Minus 4 plus 5 is 1. Then minus 4 times 2 over 3, that is minus 8 over 3. Minus 8 over 3 plus 3 is 1 over 3. Then we maintain row 2, 0, 1, 0, 1, 1. We also maintain row 3, 0, 0, 1, 1, 2 over 3. Now we realize from row 1 that x1 plus x4 is equal to a third. From row 2 we realize x2 plus x4 is equal to 1. From row 3 we realize x3 plus x4 is equal to 2 over 3. Let x4 be t. So our x4 is t. So where there is x4, we substitute t. Now from here, we realize that x1 is now equal to, when x4, which is t, crosses the other side, it will be a third minus t. x2 will be equal to, when x4, which is t, crosses the other side, it will be 1 minus t. Our x3 will be equal to, when x4, which is t, crosses the other side, it will be 2 over 3 minus t, and our x4 is just t. Now we realize that our x is now equal to, a third minus t, 1 minus t, 2 over 3 minus t, and t, which can be written as x will be now equal to a third 1, 2 over 3, 0, plus, let's factor out t into negative 1. Since t is now outside here, we're going negative 1, negative 1, negative 1, and 1. Now, the question was, calculate the homogeneous solution and the particular solution. We realize that homogeneous solution is a linear system of the form ax is equal to 0. Therefore, our homogeneous solutions will be this one, and our particular solution is in the form ax is equal to b. Actually, the particular solution, when we equate, should give us 2, 0, and 1. When we equate in the linear system of the non-homogeneous, it will give us 2. When we equate the particular. This is our particular solution. Particular solutions are in the form AX is equal to B. When you put particular solution here, it will give us 2, it will give us 0. But when you put the homogeneous solution, it will give us 0, 0. So calculate the homogeneous system. Our homogeneous system is just negative 1, negative 1, negative 1, and 1. Our particular solution is a third 1, 2 over 3, and 0. Our next question was, write the general solution of the system in vector form. Write the general solution of the system in vector form. It's actually this. When you write it in vector form, it's just a third 1, 2 over 3, 0, plus t into negative 1, negative 1, negative 1, and 1. Thank you for watching. Subscribe, like, and comment.